Okay, one more problem. Well, actually it's the same problem as the last one, but let's solve it differently. So just to recall, we had this spool which carried a thread here, and the length of the thread was 10 meters. We did mention about the mass and the radius of the spool, but somehow they were not used. But anyway, let's give it again. Radius is 5 centimeters, mass is 100 grams, and length of the thread, which is winded upon the spool, is 10 meters. And the question was, if this if you hold one end of the thread, which means the one you can hold it, and let the spool go down, then what is going to be the velocity v when this guy, well actually it was 1 meters in the last problem, so let's keep it 1 only. What is going to be the velocity of the spool? So in the last lecture we solved it using conservation of energy, but we can solve it differently also. Let's see how we can do that. We can solve it using Newton's law. So let's make free body diagram. If we make free body diagram, then we know there's a tension acting like that, and there's a force of gravity acting like this, and we need to find the acceleration. Can we find the acceleration of this object? Let's see if we can find the acceleration. Okay, also we know that the whole thing has an angular acceleration of alpha, and also the whole thing is going down with the translational acceleration of a. So the center of mass is moving down with an acceleration a, and the spool is angularly accelerating with an acceleration alpha, and we know a equals r alpha. Okay, so what can we write about this? Well, let's see. Let's write Newton's equation, assuming this to be the y-axis direction, whatever you want to label it. If you write Newton's equation, we get T minus mg equals T minus mg equals m minus a. Also, we know that there's a torque acting, so we can write T dot r, T is perpendicular to the r, equals, torque equals the I alpha. What does this give? It gives T dot r mr square over 2 alpha. So that gives T equals, let's be a little careful here. So we are assuming, you see, the torque is moving the whole thing in the counterclockwise direction, which means if you use the right hand rule, the torque is pointing out of the screen towards you. So if you define that as a z-axis, then torque is positive. So let's define that as the z-axis, then torque is positive. Similarly, alpha is also positive, because if you curl around your fingers around alpha, your thumb is also pointing in the z direction, so it should be positive. So it's I alpha. Okay, and that gives us m a divided by 2. So let's substitute this ma over 2 here. So what do we get? We get T minus mg, well sorry, I should have written this ma over 2 minus mg equals m minus a, and that gives us a equals, you can shuffle things around, 2g over 3, right? Let me check if it's 2g over 3 or not. Okay, 3, yeah, 2g over 3. Okay, we have the acceleration. So if we have the acceleration, and we started with an initial velocity 0, because there was no velocity in the beginning, so that gives us, so how should we find the velocity? We have the acceleration, we have the distance traveled. We can use the formula Vf squared equals Vi squared plus 2AXF minus Xi. Let's assume Xi to be 0. Doesn't really matter because we are interested in the difference xf minus xi. Well, that's what is given. Xf minus xi is given to be 1 meter. So Vf squared equals Vi is 0, so that gives me 2 times 2g over 3 times 1. So Vf turns out to be 4g over 3. You see, it's the same as the last. This is what we obtained using law of conservation of energy. So you see, there are two ways of solving problems in most of the time, at least in mechanics. Many problems can be solved using energy conservation as well as simple dynamics.